Hello, my fellow mathematicians. We're looking at question number 25 on the 2003 grade 7 Gauss paper. Question 25 reads as follows. The digits 1, 2, 3, 4, 5, and 6 are placed in one of the boxes so that the resulting product is correct. So we've got a two-digit number multiplied by a single digit gives us a three-digit number. If each of the 6 digits is used exactly once, the digit represented by the question mark is, not a bad question. So we're going to have to do a little legwork, see if we can work some stuff out. I'm noticing a couple things. First of all, the question mark can't be a 1. Okay? If it was a 2-digit number times 1, you'd get a 2-digit number out. And that doesn't work. Okay? But, of course, they thought of that too. And if you take a look at the answers, you'll see 1 is not one of the possibilities. 2, 3, 4, 5, or 6. Presented in no particular order. They just decided to put them in increasing order. No way to trip anything up. Okay. So it can't be 1 here. That's fine. So something we might want to consider is, where can the 1 go? Okay. 2-digit number multiplied by a single-digit number. That can go a lot of places, but I'm betting the 1 will be here. 1, or maybe it's a 2. Who knows? Okay. At best, we'd have a 6 here. The 6 on the very first digit. So I'll show you what I mean. At best, we could have something like a 6, and then a multiplying by a 5 here, or a 5 and then multiplying by 6. And that would give us about 300 something. So these are our best possibilities. So we know that we're never going to have a 4, 5, or a 6 as the third digit, the hundredths digit. We'll never have a 4, 5, or 6. We simply can't get that high. Okay? These are things that we need to consider. Okay? But I think the most important thing to consider when we're taking a look at this product is, how do we take care of regular multiplication? Okay? Let's stop and think about it. How do we do multiplication? How do I do 72 times 5? Okay? Basic by hand. I learned this stuff in, I think, 3rd grade. You guys probably learned something similar too. 5 times 2 is 10. We put the 0. We carry any 1s up here. 5 times 7 is 35 plus the 1 gives me a 36. Okay? That's how we do it. Now, the first step we did was 5 times 2, and that ends in a 0. So whatever these numbers are, let's give these guys names, maybe A, B, C, D, E, F. Okay? So ultimately what we want is C. But the first thing I notice is B times C must end in an F. And then we might carry or we might not carry a digit. Who knows? Okay? We probably will, but I don't know. So that sort of limits what we can do. Let's take a look. We've got some possibilities here. Doesn't matter the order in particular. So let's say we'll put B's here. So our candidate B's and our candidate C's. And we're going to make a nice little multiplication table, just like I learned back in grade 3. And we're going to see not the numbers that we actually get, but the number that we end up with. Because it needs to be B times C. They need to be distinct numbers, because you can't have 1 in both places. So we don't need to worry about these. The 4 times 4, the 5 times 5, and the 6 times 6. They're only going to waste our time. But we need B times C, and we need to end in an F, and all 3 numbers need to be different. Okay? So 2 times 1, that ends in a 2. Well, no, we've already got a 2. So no. 1 times 2, similarly, that's not going to work. None of the ones with a 1 are going to work. Because you'll have, 1 times 4, but that ends in a 4, but we already used 4. So B and F can't both be 4, for example. Okay, fine. 3 and 2, that gives us a 6. That could work. Same thing, 2 and 3, it gives us a 6. The order doesn't particularly matter, but we'll fill out the chart anyway. 2 and 4, that makes 8. But we don't have an 8 to put in for f. Okay, similarly, we can't use an 8 down here. 2 times 5, that ends in a 0. That's also not going to work. 2 times 6, that's 12. That ends in a 2. That's not going to work. So far, that 6 is looking pretty good. We're using red to cancel out the numbers that we don't have, black to cancel out the cases that we can't consider. 4 times 3, that's 12. That ends in a 2, and that would work wonderfully. 3 times 5, that's 15. That ends in a 5. That's not going to do. 3 times 6, that's 18. That ends in an 8. And that's just not a number we have. We can't make F8. We don't have an 8 on standby. We don't have an 8 as our possible numbers. Okay, 4 times 5, that's 20. That ends in a 0. We don't have a 0 on hand. 4 times 6, that's 24. That ends in a 4, and that just won't do. Okay, and finally, 5 times 6, that's 30. That ends in a 0. And that is also just not a number we have. Okay. So of our possibilities, we could have B and C be 3 or 4, and then F would have to be 2. Or we could have B and C be 2 and 3, and then F would have to be 6. So far, 3 is in both of these. So far 3 is in both of these. So C being 3 is looking pretty good. But we know that C is going to be 2, 3, or 4. It can't be 5. It can't be 6. There's no way that's going to happen. And that already narrows down our possibilities. It's going to be A, B, or C. The answer can't be D. The answer can't be E. So at least whatever I do, I'm not going to bubble in D or E. Okay? We might just have to do some process of elimination stuff here. Now, let's go back to it and take a look at what else we could have. So, let's suppose, right, I don't really have anything I can do right now. Nothing's popping to mind. So I'm going to guess that B is 2, C is 3, and that makes F 6. Okay. So I've got A left, I've got 2 here, got a 3, and I've got a 6, a blank, and a blank. And I don't carry a 1. Right? If it was 3 and 4, we would be carrying a 1 to get, because we'd have 12, so we'd carry a 1 up here. But we don't have that. So we have 4, 5, and 1 left to play with. 4, 5, and 1. Okay? So, whatever this 2-digit number here is, it's going to be 3 times this number. So 3 times A is DE. Okay? Well, what could A be? It could be 1, it could be 4, or it could be 5. So 3 times 1 is 0, 3. No, that's not going to work. 3 times 4 is 1, 2. Well, no, I need it to be a 5 and a 1. And 3 times 5, that's going to be a 1. That's going to be 15. That's not going to work either. So we've got a bit of a problem here. Okay? None of these work out. And you'll notice that this mattered with the 3 here. What we can do is the same sort of thing, but put the 3 up above and the 2 down below. The 2 being the number that we're multiplying, the single digit. Okay? But we exhausted our possibilities. We had 2 times 3, nothing to carry, so nothing gets added on here. If we had a 1 to carry, this would be 3A plus 1 is equal to DE as a 2-digit number. Okay? But we don't have that. So let's flip it around. We've only got 4 cases to work through. How about we try each of them? Until we come up with something better, and 4 cases is not bad. So how about we put the 3 up here, and now we've got the 2 down here. We've got our 6 here, and we've got D and E. We still haven't carried anything, but now we've got 2 times A must be equal to our 2-digit number DE. Not D times E, just DE written in order. So technically, I guess that's 10D plus E. Okay. And what numbers do we have left over? We have a 1, a 4, and a 5. Well, those are our possibilities for A. A 1, a 4, and a 5. But 2 times A is not a 2-digit number. 2 times 4. So A is 4. 2 times A is not a 2-digit number. 2 times 5, that's 10. That's great. But we need it to be 1 and a 4, not a 1 and a 0. Otherwise, we haven't used all the digits. Okay, not bad. So now we know that this can't be a 6 here. It's got to be the case where we've got 3 times 4 and the 3-digit number ends in a 2. Okay. So that tells us F can't be 6. So as F is 2. If F were 6, one of these two cases, the only ones that end in a 6, would have worked. So F is 2. So we've got two cases where F is 2. We can have a 3 and we can have a 4 here. That gives us a number here, and it ends in a 2. But this time we have a 1 that we've carried. We have A, and then we have D and E. So now 4 times A plus the 1 that we carried must be equal to my 2-digit number DE. And what numbers do we have left over? We have a 1, a 5, and a 6. So we have different possibilities for A. Let's do 4 times 1 plus 1. That better have a 5 and a 6 in it, but no, it's just a 5. Not a 2-digit number at all. How about 4 times 5 plus 1? Well, that's 21. That's at least a 2-digit number, but it doesn't have a 6 and a 1 in it. How about 4 times 6 plus 1? That's 24 plus 1, that's 25. We got our 6 and our 5, but we've got this pesky 2 here. So no dice. So unless I've done something horribly wrong, and I'm not ruling that out, we have only one more case to go. So it's got to be the 4 on the top, C is 3, and our last number is 2, the last number of our 3-digit number. Now remember what the question's asking for. We just need to know what that single digit is. And if we're really confident, we know it's got to be the case where that's a little 3. That C value is 3. So if we wanted to, we're done, and we bubble in, I think, B. Yeah, so the answer should be B. But what I'm going to do is I'm going to go through this case and make sure that this works. Because otherwise I've made a goof somewhere. I've done some sort of error, something wrong. You know, maybe one of you out there can see it and you're screaming at the screen that, how could you be so foolish? But it should be the case that we get the 4 up here, the 3 down here, and the 2 down here. So this would imply an answer of B for our question. Now, we get 4 times 3 is 12. We put the 2 here. We carry the 1. We got A, and we've got DE. What's left over? Still the 1, the 5, and the 6. Okay, that hasn't changed. But now we've got 3 times A plus 1. Needs to be the 2-digit number read as DE. So what are our possibilities for A? 1, 5, and 6. So 3 times 1, 3 times 5, 3 times 6, and we add 1 because we're carrying the 1 from the 12. So 3 times 1 plus 1 is 4. Not a 2-digit number, so that's not going to work. It can't be DE. 3 times 5 plus 1, that's 16. That works. And we don't really need to go any further, but 3 times 5 plus 1 is 19. That doesn't work because we don't have a 9 to put in for E. Okay. So this one worked. I mean, if you'd done your cases the right way, this would have been your first one. But there was no hint as to which one to look at first. So the single digit is 3. And that gives us an answer of B. And just to show off, the multiplication is A is going to be 5. So 5, 4, 54 times 3 is 162. And I can even go through and double check that on my calculator. 54 times 3, 162. I love it. It's great. So that's a nice little thinking question. We had to do a little work to narrow down our options. We had to think about it and say, what sort of single digits can we get? How do we multiply? That sort of stuff. And then maybe there was a way to simplify it further, but I liked having just 4 cases to work with, and we worked through them, and it just so happened that the last one was the one that worked. and we got 54 times 3 is 162. If you're good with numbers, you might have been able to just guess at that. Okay? But either way, we get our answer of 3 and 3. Let's just double check because I'm a little paranoid right now, but yeah, it's 3. B, 3. Okay. And that does it. That's question number 25 on the 2003 grade 7 Gauss. Nice little paper, in my opinion. And if you're looking for the grade 8 Gauss, I'm sure I'll have that up sometime soon. So stay tuned for that. Or if you're looking for another grade 7 Gauss, I guess 2004 is the next one on my list. So look for that in the future. Okay? Thank you guys for watching. As always, if you want to, feel free to like or subscribe or any of that sort of YouTube stuff. And either way, I'll see you for more math contests in the next video.